Hey guys, this is going to be a quiz that's labeled under Introduction to Acids and Bases, a little bit in 18, specifically 18.1. All right, so make sure you read through the properties of acid make, like the neutralization lesson. The big one I want to point out is the fact that acids and bases are both considered electrolytes. Strong acids completely ionize into ions, so even though they're covalently bonded, they're a special group that will ionize and actually react ionize into water. Strong bases will completely dissociate into ions. They're already ionic compounds, so simply once they get dissolved into water, those ions the water. So strong acids and bases are strong electrolyte, a large current. Weak acids and weak bases only ionize, so since there's less mobile charged particles, ions, so they'll only conduct a small current. Make sure you just kind of look through the different common household uses of various acids and bases. They're in a variety of products that we use. So the first kind of base in acids and bases falls under the Arrhenius definition. So this classifies substances in terms of their formulas and their bases hydrogen ions. So the hydrogen will ionize from the rest of the compound and producing that hydrogen ion, Arrhenius acid. An Arrhenius base is a substance that into water. The bases fell into these definitions, which is as we move forward in this unit. Now, one thing to point out with acids is that hydrogen ion that they produce, we really talk about most of the times in terms of the negative pole of the water molecules where that oxygen is so strongly that it forms a covalent bond with one of them. So we show this interaction by writing that hydrogen ion as H3O plus ion, which is referred to as the hydronium ion. So you'll see both here. All right, this group of strong and weak acids and bases, you're going to have strong ones. So if you kind of memorize all the strong ones, the rest you'll be able to recognize as your weak acids and bases. So these 6 strong acids you absolutely have to know. Basically anything else that we're going to come across for the most part. Bases, some of the smaller or lighter group 2 hydroxides aren't always soluble, so the textbook doesn't tend to go. But if you keep in mind group 1, group 2 hydroxides are your strong bases, everything else weak. Speaking about acids and our strong ones, and the textbook used dissociate, but it's really ionize. That will react with the water to produce the hydronium ion and then the leftover negative ion. Because it's a strong acid and it will essentially complete this process, arrow for the reaction. You'll see here in this graphic from the textbook that you have the entire strong acid and will ionize all of it, hydronium, into water. For weak acids, they only ionize slightly into ions in water, which creates an equilibrium. Why you're going to see a double arrow used calculation, and we'll get into that as we move forward. So you can see from the graphic, just a little bit once placed into water is actually going to ionize into hydronium. So in the AP chemistry reference tables, based on the equation I shared with you on the slide before, water is a pure liquid. It's left out of the Ka is just like any other point in terms of K. So Ka, just remember, just like far to the right towards the products, the reaction has proceeded to reach equilibrium. So the value of the Ka is an indication of acid strength. So the stronger the acid, the higher the hydronium concentration, the larger the Ka value. And I kind of look at it sometimes going backwards. The bigger that Ka value, the greater the amount of hydronium that's been in solution, the stronger the acid's going to be. This chart kind of just goes through some of the examples in terms of looking at Ka values for these, what we consider weak acids, but there's still quite a range between them. That you have to know, 3 of them fall under an oxoacid, where the number of oxygen atoms has to exceed the number of weak acids, which are all your other acids. You have H halogen, so you have a couple examples there. You have some other, just the number of 2, and then I would just make sure you star this by acids, and you'll see it written as COOH. That hydrogen ion can ionize and acts as a weak acid. So just be on the lookout for these 6, but also especially for the carboxylic acids, because you'll see those and come across those from time to time, because most other acids are going to have hydrogen out in front except for those. Your strong bases, again, group 1 and group 2, be on the lookout for a nitrogen atom. Because of that lone pair, it's going to act as a weak base. Alright, so take a second, if you haven't yet, and try these out, see if you can identify them, and then pause it, and then I'm going to pop up the answers for you. You have that CO is a strong acid. You have the hydrogens that can ionize, so it's actually going to act as a strong acid. And the last one is a weak base based on that nitrogen. Again, that lone pair is going to, in this case it's referred to as an amine, is going to allow it to end up. So again, we just kind of mentioned this idea of And the reason why this is important to talk about neutralization reactions. This part you actually would have to fill in on your notes. So when Arrhenius acids and bases react, the H plus from the acid is going to react with the hydroxide OH group from the base in order to form water. So this is kind of your molecular equation of a generic acid and a generic base that are going to react and produce water. So if we look at kind of each piece of it and really our net ionic equation for neutralization, you'll see where this comes from. So we have hydrochloric acid and barium, just check it. And we're going to see that when we separate out the ions, except for water, because water is a pure liquid, it's not aqueous here, so we need to leave it put together, just like our other double replacement reactions. We get this equation, chloride ions, potato ions, ionic equation, which then we could even simplify to have a one reaction. This basically goes over that as well. Just keep in mind that the generic form is in order. Just realize that not all acids and bases are kind of equivalent in strength to each other. So while they'll formally have to have a pH of 7, which we'll get to, even though this process is referred to as neutralization. The other thing I would be aware of, and I would actually be aware of this value, I've seen it come up in a question, is that for acid with a strong base, the always equal to negative 55.9 kilojoules per mole for each mole of water. And again, this is going to be the same because every reaction, that net ionic equations don't affect that enthalpy value. So just be able to that net ionic equation for all neutralization reactions. All right, writing ionic equations, this is simply a double replacement reaction. So try it out, see if you can break it down into the total and net, and then pause it and just come back and check it. Okay, here's your double replacement, or sometimes referred to as your molecular equation. The total ionic, making sure you keep the water together. Your hydrogen ion plus your hydroxide ion produces water, and your spectator ions are just your potassium and chlorine ions. All right, I know that was quick, but I just wanted to give you the other AP chemistry teachers I posted. All right, I hope you guys are all doing well.